Hey guys, we're going to be going over example 4 for section 3.2. But before I do, I definitely want to talk about some of the stuff that's in your notes. We talked about representations of functions, but now when we're graphing linear functions, and this is a big concept, solution of a linear equation in two variables. So we've gone over the solution of an equation several times. The solution to an equation is a value or values for the variable that you can plug into the original statement and it's true. Now we have two variables though. So we're going to notice some other things happen, okay? So let me go. I just want to make sure this is explained very well. So just think about the equation x plus y equals 5. So if I say what are some things that work? Well, x could be 0, y could be 5, right? So now we have one answer. We'll just do this as a column xy. So we have x could be 0, y could be 5. Well, x could be 1, and then y could be 4. 2 plus 3 is also 5. And couldn't I switch them? So then I could say x, it could be my 3, and y could be my 2. So now I have a whole nother set of points. Then I could also go 4, 1, and then 5, 0. Sorry about that. That's a 5. So now we have all these possibilities, and that's what an ordered pair is. It's the connections. It's the x and y that have to be connected. Now, let's go beyond this, though. Don't we have negative numbers? So we could think about -1 and a 6. You think about -2 and a 7. You see how we could do this forever? We also need to think about decimals. We could have 0.1 and 4.9, 0.01 and 4.99, 0.001 and 4.999. Do you see how it can go on forever? So when we're thinking of solutions with two variables, depending on the story problem, it is possible to have an infinite number of solutions. And not only is it possible, it's actually typical. So now let's get back into the book and see what they're going to describe this as. So depending on how the problem goes, you could have a discrete domain or a continuous domain. So if I was counting people, I would count 1, 2, 3, 4, 5 people. That's discrete. Discrete is distinct points. So discrete, distinct. Okay? When you have discrete, it means you can't have a part of something. You can't have a part of a person. Now, continuous. This is something if I measure like time from 1 second to 5 seconds. Well, in all of those time frames, isn't there a 1.2969854329282 seconds? It's very specific, but there is that decimal point, just like there's 2.9468334. So while I cannot tell you every possible second to the decimal that goes by, they are all contained in here from 1 to 5. And that matches up with us doing domain and range in 3.1. So I just want to make sure that was clear, talking about discrete and continuous. The easiest way to remember it, continuous, you could draw it in one continuous motion without ever lifting your pencil. Discrete, you have to lift your pencil. Okay? So now let's get into the final examples. So here we have a linear function, y equals 15.95x, represents the cost in dollars of X tickets for a museum. Each customer can buy a maximum of 4 tickets. So let's make sure all this makes sense. Y is our dependent variable because it depends on the number of tickets X. So the cost is $15.95 per ticket. That is actually seen inside here because remember, when you multiply which is 15.95 times x. It means for every. So now we know that's 15.95 for every ticket. Find the domain of the function. So this one, the domain is each person can only buy up to 4 tickets. So a person could buy theoretically 0 tickets, 1 ticket, 2 ticket, 3 tickets, or 4 tickets. And it is not possible to buy a half ticket. So when you look for the domain, what are all the different possible scenarios or possible different ways that you can buy tickets? So since you cannot buy part of a ticket, only certain number of tickets. That means we are looking at a discrete graph. And now while X represents the number of tickets, it must be a whole number. The maximum tickets is 4. So the domain is you can buy 0, 1, 2, 3, or 4 tickets. Remember, domain goes with X, which goes with independent variable. So what you're thinking is, what are all the numbers I can use to represent my independent variable for the number of tickets? And then we're going to graph it using the domain. This is what I've been saying in class. Your input is your domain. Your throughput is what happens to it. The output is what you get out. And then you write in order to pair so we can graph it and start looking at the information. So now 0 times 15.95, 0. It better cost $0 for 0 tickets. That makes sense. 1 ticket, 15.95. 2 tickets, 31.90. 3 tickets, 47.85. 4 tickets, 63.80. And then you can plot your points. And notice you have a title. This is what the Y or the dependent variable was, the number of dollars spent. This was your X or your independent variable, the number of tickets that could be bought per person.